Good morning everyone. In the last video, we have seen that the value of magnification gives us so many things like nature of image, the relative size of image with respect to the object, and which type of mirror is that by which the image is formed. Not only that, during that time we have revised some of the equations related to the mirror, and today we are going to again see this type of equation. The first one is the mirror's formula, which is 1 upon v plus 1 upon u equals to 1 upon f, where v is image distance, u is object distance, and the f is focal length. The magnification of an image in which the m is equal to h dash by h, where the h dash is the image height and the h is the object height. Not only that, the another equations of magnification is m equals to minus v upon u, where v is image distance and the u is object distance. There is one another equation which is relation between radius of curvature and the focal length. What is the equation? The equation is r is equal to 2f. If you take these two in the another side, then you get r by 2, which is equal to f. When we will saw terms related to the spherical mirror, during that time I have said that the relation between r and f is that the f is the half of the r. As you know that whenever we draw a mirror like that, there is pole and the center should be taken as C. The distance between C and P is the radius of curvature, and we have put f exactly at the half distance. If it is 6, then it is 3, which is small f, focal length. So the focal length is the half of the radius of curvature. The radius of curvature is twice to the f. Understand? So like that, here it is the relation between r and f. You have to use these equations in your example. In examples related to the mirror, you have to use these 4 equations, right? Now, so we are going to see some of the examples related to mirror. So now open a book, example 10.1. Okay. What is the question? The question is a convex mirror used for rear view on an automobile has a radius of curvature of 3 meters. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meters. If a bus is located at 5 meters from this mirror, find the position, nature and size of the image. हमें इस तरह का क्वेश्चन दिया गया है, उसमें से सबसे पहले हमें कौन सा डेटा बाहर निकालना है? The first data is the which type of mirror is there. So first of all, the type of mirror is convex mirror. That mirror is convex mirror, and if the mirror is convex, then you can say that f is positive, right? In the last video I have said that the for a convex mirror f is positive, for the concave mirror f is negative. Right? So according to it, f is positive for the convex mirror. Okay. According to this example, what types of data is given to you? The first of all, in a rear view mirror, an automobile has a radius of curvature. Radius of curvature, which is denoted by capital R. That's 3 meters. F is positive, so we have to take R as a positive because it is twice the F. If F is negative, then you have to take R also negative, right? Okay. If a bus is located at 5 meters from the mirror. Okay, there is one mirror and bus is at here. So according to it, you can say that the bus is an object for the mirror. And you have to find what the position of the image of that bus. So bus as an object. So the bus is located at 5 meters from the mirror. So you can say that it's an object distance, which is denoted by U. So the U equals to 5 meters. But as you know that the object distance is always taken as negative. I have said it in a Cartesian sign convention. During Cartesian sign convention, I have said it that the U means an object distance should be always taken as negative. So the U is minus 1 meter. Now what you have to find? Find the position, nature and size of image. So position. Position means you have to find out V. Nature means you have to find out M. And you can't find the size, you can only find the relative size because the object size is not given to you, right? So you have a U and R, right? And you have to find out V. As you know that for finding V, you can use a Miller's formula. What is Miller's formula? It's a 1 upon V plus 1 upon U is equal to 1 upon F. So you want to find out V. For that you need U. U is given to you. F. There is no value of F. But as you know that with the help of R you can easily find out F. What is the equation? The equation is that R is equal to twice. So R by 2 is equal to F. R is 3 by 2 equals to F. So F is equal to 1.5 meter. If you divide 3 by 2, then you get 1.5. Right? So like that, you have the value of F, you have the value of U, then you can find out value of V. At here, you want to find out 1 upon U. So 1 upon F. Take this 1 upon U in the another side of equal to. It is positive and it becomes negative. Right? Now, F is positive, so 1 upon 1.5 minus. U is minus 5. Right? So at here, if we remove a point, then 10 by 15. This minus minus becomes plus 1 upon 5. So the 1 upon V equals to 10 by 15 plus 1 upon 5. You have to take the LCM of 15 and 5, which is 15. So 1 upon V is equal to 10 plus 3 upon 15. 10 plus 3 means it's 13 by 15. Right? At here, you have to do the LCM. Right? If you do LCM, then what types of things are there? 15. Right? Plus 1 upon 5. The LCM is 15. So if you multiply 15 by 1, then it gives you a 15. If you multiply by 1, then you have to multiply 1 as a also. 5 3s are 15. So you have to multiply it at here also a 3. And just because of that, it gives you a 10, it gives you a 3. And the common denominator is 15. 15 ones are 15 and 5 3s are 15. So it's a 15, it's also 15. So denominators are same. So you have to take the direct addition of numerator, which is 10 plus 3. So the 10 plus 3 by 15, which gives you 13 by 15. But it is the value of 1 upon V. So if you find out V, then you have to take an invert of it. If you take inversion, then the V by 1. So you can write a V. If you take this invert, then you have to do also at here the same thing. So it becomes 15 by 13. It's a meter. So V is equal to 15 by 13. If you find out more, then you have to do a division of it. Okay? So at here V is equal to 15 by 13. Now, with the help of this V, you can find out M. With the equation of magnification of an image. What is it? It's a M is equal to minus V upon 2. So the minus V is 15 by 30. And what is U? U is minus 5. It's an upper one in which there is a numerator, there is a denominator. Already this denominator is as a denominator just in a down direction means. So you have to take that here also. U is a minus 5 which is already as a denominator. So 15 by 13 into minus 5. This minus minus becomes plus and it gives you 15 by 13 into 5. 5 3s are 15. So M is equal to 3 by. The value is positive. So you can say that image is virtual. And by the way, you know that with the help of convex mirror, the image is always virtual. So here it is, the image is virtual. And as you see at here, the numerator is less than denominator. Just because of that, this image is diminished, right? It is smaller than the object. Understand? So just see for 2 to 3 seconds. Okay, now one another examples. Example 10.2. Example number 10.2. What is the question? The question is that an object 4 cm in size is placed at 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. So first of all, which type of mirror? An object 4 cm in size is placed at 25 cm in front of a concave mirror. So it's a concave mirror. So mirror is concave, so you have to take a F as a negative. Right? F as a negative. Now what is the value of F? Is it F is given to you or a I? An object 4 cm in size. So object size is 4 cm. So size of an object is H, which is 4 cm. Size, not a distance. Size is placed at 25 cm in front of a concave mirror. It just placed at 25 cm from the concave mirror, which is the distance of object, which is you. It's a minus 25 cm. One object of 4 cm size is placed at 25 cm in front of concave mirror. So 25 cm is the object distance, while the 4 cm is the size of an object, right? In front of a concave mirror of focal length 15 cm. So focal length is given to you, which is 15 cm, and it should be taken as negative because it's a concave mirror. At what distance from the mirror should a screen be placed in order to obtain a sharp image? You want to obtain a sharp image. Where should you put a screen? If you want an image, then you have to put a screen at that point where image actually formed. So according to it, you have to find out the position of an image. On position of an image, if you put a screen, you get a image, sharp image on it, right? Find the nature. For nature, you have to find out M, and find the size. Object height is given to you, so you can easily find out the size of an image also, right? So for that, first of all, we have to find out V with the help of U and M, which is Miller's formula. So Miller's formula, 1 upon V plus 1 upon U is equal to 1 upon F. You want to find out V, put this 1 upon U in the other side, then 1 upon V is equal to 1 upon F minus 1 upon U. Now what is 1 upon F? It's a minus 15 minus U minus 25. So it's a minus 1 upon 15 minus plus 1 upon 25. Just take it and above, then it's 1 upon 15. Ahead you have to take it as a positive and that negative. Just I replace the places. You can do it, right? Because 1 upon 15 is plus and the minus is 1 upon 15, right? So, sorry, 25. So at here, you have to take the LCM of it. What is the LCM? 25 means 5 5 and here 5 3 common is 5. So 5 5 is 25 into 3, which gives you a 75. So 25 3s are 75. So 3, right? And 15 5s are 75. So 5 into 1, 5 and 3 into 1. So 3 minus 5 is 75. So what is the answer? 1 upon V is equal to minus 2 by 75. So according to it, the V is minus 75 by, if you just do a division, then what is your answer? The answer is V equals to minus 37. .5 centimeter. So V is minus 37.5 centimeter. Is the image distance. So image. So we have to put a screen. At 37.5 centimeter from me. Minus means it gives you an image in the side of object. If the object is at here, image will also form in this same side. It is not in the other side of the image. So it gives you a minus. But you have to put an object at here. At here also, in an example, the U is given to you 25 cm. There is no minus. But we have to put a minus according to Cartesian sign convention. So at here also it is a Cartesian sign convention. According to it, this minus is there. But the distance should be put as a positive, right? So the screen should be put at the 37.5 centimeter from the mirror. Minus is according to Cartesian sign convention. Now you have to find out the M. So M is equal to minus V upon U. You can't use H dash by it because you want to find out M. You does not have the value of H dash and the H is given to you, but there is 2 unknown. You can't use it. At here, the 2 of the value is given to you. You can find out M. So at here, M is equal to minus 37.5 divided by U is minus 20. This minus cancel out. Minus 37.5 means you can write like that 75 by 2 into 25. 37.5 means at here 75 by 2. 25 is a 75, so it gives you minus 3.2. M is equal to minus 1.5. It's a minus, so image is real. Now you want to find out H dash. For them you have to use the same equation of magnification, but H dash by H. Now you know the value of H, and with the help of this equation you get the value of M. Okay, M does not have any unit, right? So at here M is equal to minus 1.5 H dash and H is equal to 4. So at here minus 15 by 10 into 4 is equal to H dash. I have just removed a point and there is multiplication of F because at here it is division. If I put in the other side of the equation, it becomes multiple. Okay, 5 threes are and 5 twos are. 2 twos are 4, 3 twos are 6. So minus 6 centimeter is equal to h dash. So h dash is equal to minus 6 centimeter. So you can say that the size of image is 6 centimeter. So here it is the size of. Understand? These data are given to you. According to it, with the help of Mirror's formula, you can find out the v by putting the 1 upon v is equal to 1 upon f minus 1 upon u. If you put a value of a, then the f is negative, u is also negative. This minus minus becomes plus. Just put it ahead of the 1 upon 15. Because it's a plus, it's minus, it can be easy for you. So 1 upon 25 minus 1 upon 15. You have to take the LCM, which is 75. According to it, the 3 minus 5 is 75, which gives you minus 2 upon 75. You need v, not 1 upon v. So you have to take the invert of it, and the v is equal to minus 75 by 2. If you do a division, then you get v equals to minus 37.5 centimeter. For finding the nature, you need to use m is equal to minus v over u, where the v is minus 37.5 and the u is minus 25. This minus minus cancel. As you know that 37.5 is just out of the 75 by 2. So you have to put the value of 75 by 2 into 25. 25 3s are 75. So m equals to minus 3 over 2, which gives you a 1.5. And it is minus, so it's a real image. Right? Like that. If you want to find out h dash, you have to put the same equation. M equals to h dash by h. Just put the value of m and the h, then you get the h dash, which is 6 centimeter. Okay? Here it is the sum. Just say it for the total distance. So here it is your two examples related to the mirrors, right? You have to write down example number 12, 14 and 15 from the exercise in your notebook. It's your homework, okay? Thank you.